Hi and welcome. In this video, we're going to talk about basic physics, how the world around us actually works, why things fall, how light moves, and why we even stay on Earth. Let's go! Everything in the entire universe is made of atoms. You, me, the air we breathe, the water we drink, even the stars in the sky are made of atoms. You could say atoms are nature's building blocks, like Lego bricks that build up everything around us. An atom has a center called the nucleus. In it are protons, which are positively charged, and neutrons, which are neutral, neither plus nor minus. Electrons orbit around the nucleus, and they are negatively charged. It's the interplay between these charges that allows atoms to stick together and form substances. When many atoms bond to each other, they can form everything from water and oxygen to rocks, plants, and ultimately, us humans. Pretty amazing, right? Each unique kind of atom is called an element. That means if you have atoms that all look the same, with the same number of protons in the nucleus, then you have one and the same element. For example, hydrogen has just one proton in its nucleus. Helium has 2. Oxygen has 8. So it's the number of protons that determines which element it is. Together, all the elements make what's called the periodic table, a kind of map of all the atoms we know in the universe. Some elements, like oxygen and hydrogen, are super common and are found everywhere in nature. Others, like gold and uranium, are rare and used in special situations. So next time you look at something around you, remember that at the core, it's just different combinations of elements, arranged in an absolutely fascinating way. Everything around us, absolutely everything, is made of matter. But what does that actually mean? Matter is anything that has mass and takes up space. That is, has volume. This applies to everything from a rock to your phone, from the ocean to the air you breathe. Matter can also appear in different ways depending on how warm or cold it is. When a substance is cold and hard, we call it solid, like ice. When it melts, it becomes liquid, like water. And if you heat it even more, it becomes a gas, like water vapor. The cool thing is, it's the same substance the whole time, just in different forms. So the next time you see water flowing, ice glittering, or steam rising, think of it as matter changing its shape. When we talk about how much something weighs, we often use the word weight. But in physics, we actually say mass. Mass is about how much matter, how much stuff an object contains. In everyday life, we say weight when we, for example, weigh ourselves or weigh ingredients in the kitchen. But what we're really measuring then is mass, how much matter the object contains. Mass is measured with a scale, just like you see here, and the unit we use is grams, or sometimes kilograms. So when you say you weigh 50 kilos, what you really mean is that your mass is 50 kilos of matter. Volume is about how much space something takes up, the amount of room an object or a substance occupies. Think of the difference between a small glass and a big bucket. They have different volumes because the bucket holds more. Volume is often measured in liters or cubic centimeters. That is, centimeter times centimeter times centimeter. 1 liter of milk means the milk takes up a certain amount of space in the carton. In a lab, you can measure volume with a measuring cylinder, like you see in the picture. If you lower an object into water, you can see how much the water level rises, and then you know the object's volume. So volume is simply about space, how much room something takes up in the world. Density is about how compact a substance is, how tightly its atoms are packed together. Imagine you have a wooden block and a stone that are the same size. The wood floats, but the stone sinks. Why? Because the stone has a higher density. It contains more matter in the same space, meaning more atoms packed tightly together. You can calculate density by taking the mass and dividing it by the volume. How much something weighs in relation to how much space it takes up. If you have a metal cube that weighs 200 grams and takes up 50 cubic centimeters, you divide 200 by 50 and get a density of 4 grams per cubic centimeter. The higher the number, the denser and heavier the substance feels. So density explains why some things float and others sink. Have you ever tried balancing something tall and narrow, like a bottle, and noticed how easily it tips over? That's about stability. An object's stability depends on two things: center of mass and base of support. The center of mass is the point where all the mass of the object can be thought of as being concentrated. If you could hang the object from that point, it would be perfectly balanced. The base of support is the area between all the contact points with the ground, the area the object stands on. The larger the base of support and the lower the center of mass, the more stable the object is. Think of a sports car. It's low and wide, so it won't tip over in turns. Or a building with a wide foundation so it stands firmly. But if you raise the center of mass, like with a bus or a tall cabinet, it's easier for it to topple. So, low center of mass and large base of support. That's the key to stability. Isaac Newton was one of the greatest scientists in history. He lived in the 17th century, and his discoveries changed how we understood the world and the universe. You've probably heard the story about Newton sitting under a tree and seeing an apple fall to the ground. He started wondering, why does the apple fall straight down? Why doesn't it fly sideways or upward? That question led him to investigate forces and motion. He realized there is a force that pulls all things toward Earth's center, a force we call gravity. Newton didn't just explain why things fall. He also explained why the moon stays in its orbit around Earth and why the planets move the way they do. His ideas became the foundation of much of the physics we still use today. Forces are all around us, even though we can't see them. We notice them all the time. For example, when we push something, pull something, or when something falls to the ground. A force is something that acts on an object. It can make it start moving, stop, change direction, or change shape. Forces also hold matter together, like when Earth's gravity keeps us on the ground. Force is measured in the unit Newton, to honor Isaac Newton and his work on motion and gravity. To measure a force, you use a tool called a dynamometer. The more force you pull with, the more the spring stretches. So even though forces are invisible, we can always see their effects on everything that moves, stops, or changes. Anything that has mass is pulled toward Earth. That's called gravitational force, or attraction, or simply gravity. It's the force that keeps us on the ground and makes apples, balls, and everything else fall downward. Gravity acts on all objects, whether it's a rock, a person, or an airplane. It always points downward, toward Earth's center. The greater the mass something has, the stronger the gravitational pull. And the farther you get from Earth, the weaker it becomes. That's why you feel lighter on the moon. Gravity there is much weaker. On Earth, roughly, a force of 10 newtons corresponds to 1 kilogram of mass. So if you have a mass of 50 kilograms, Earth pulls you downward with about 500 newtons. Gravity is invisible, but it holds everything together, from our feet on the ground to the planets in their orbits around the sun. Now let's look more closely at the difference between mass and weight. Mass tells you how much matter something is made of, and it's always the same, no matter where you are in the universe. But weight, that can change. Weight is about how strong the gravity is where you are. The stronger the gravity, the greater the weight. And the weaker the gravity, the lighter you feel. The formula for weight is weight equals mass times gravity. If you have a mass of 60 kilograms, Your weight is about 600 newtons on Earth. But on the Moon, where gravity is only 1/6 as strong, your weight would be just 100 newtons. On the Sun, though, where gravity is enormous, your weight would be over 16,000 newtons. So your mass is always the same, but your weight depends entirely on where you are in space. Friction is a force that slows motion. It appears when two surfaces rub against each other. If you try to push a heavy box across the floor, you feel resistance. That's friction pushing back against the motion. Friction is actually very useful. Without it, you couldn't walk, drive a car, or even hold things. Everything would just slip around. But sometimes we want to reduce friction, for example in an engine or in a ball bearing, so things can move more easily. Then we can use lubricating oil or materials that slide better. In other cases, we want to increase friction, like when driving on winter roads. Then you need winter tires or sand so the tires grip the road. So friction can both help us and cause problems, but it's always there, an invisible break between surfaces moving against each other. Isaac Newton didn't just come up with gravity. He also managed to explain how all forces and motions fit together. To describe this, he created 3 simple but super important laws that are still used in all of physics today. These laws are about why things start moving, why they stop, and how forces always interact with each other. You can see them everywhere, in sports, when you cycle, drive a car, or just drop something on the floor. Now let's take a closer look at what Newton's 3 laws actually say, and why they still help us understand how the world works. Newton's first law is called the law of inertia. It's about how things prefer to keep doing what they're already doing. If an object is at rest, it stays at rest until something acts on it. And if an object is moving, it keeps moving in the same direction and at the same speed until a force slows it down or changes its direction. A clear example is when you sit in a car that suddenly brakes. The car stops, but your body keeps moving forward. That's why we need seatbelts and airbags to stop the body safely. Inertia is everywhere, in everything that moves or stands still. In short, things like to continue as they are until some force says otherwise. Newton's second law is about how forces, mass, and motion are related. It says that the force on an object depends on how heavy it is and how much it accelerates. That is, how quickly it changes speed. The formula is simple. F equals m times a. Force equals mass times acceleration. That means the greater the mass of something, or the faster it accelerates, the more force is needed. That's why it's much harder to shove a heavy box than a light one. If you push a box that has a mass of 10 kilograms and it accelerates at 2 meters per second squared, the force is 20 newtons. But if you accelerate a car that has a mass of 1,000 kilograms at 3 meters per second squared, then you need a full 3,000 newtons. In short, the heavier something is, or the faster you want it to change speed, the greater the force required. Newton's second law shows how forces work in practice. Imagine you're going to push a box that has a mass of 10 kilograms. You push so that it starts moving faster and faster. That means it accelerates. If the box has an acceleration of 2 meters per second squared, we can calculate the force with the formula F equals m times a. That's 10 kilograms times 2 meters per second squared, which equals 20 newtons. That means you're using a force of 20 newtons to get the box moving. And the heavier the box is, or the faster you want it to accelerate, the more force you'll need. Let's take another example, this time with a car. Imagine a car that has a mass of 1,000 kilograms. When the driver steps on the gas, the car accelerates. It increases its speed by 3 meters per second every second. Using the formula F equals m times a, we get 1,000 kilograms times 3 meters per second squared, which equals 3,000 newtons. That means the car's engine delivers a force of 3,000 newtons to make the car accelerate. And just like with the box, the heavier the vehicle, or the faster you want it to speed up, the more force the engine needs to provide. Speed is about how fast something moves, how much distance you cover in a certain time. The formula is S equals V times T, where S stands for distance, V for speed, and T for time. Think of it like this. If you know how fast you're moving and how long you keep going, you can calculate how far you'll get. For example, if you run at a speed of 5 meters per second for 20 seconds, you'll cover 5 times 20, that is 100 meters. Speed is used everywhere, when driving a car, cycling, running, or even when measuring how fast light travels through space. Newton's third law is about how every force has an equal and opposite reaction force. That means if you push on something, it pushes back with an equal force, but in the opposite direction. For example, when you jump off a boat, your legs push against the boat, and the boat moves backward. You give the boat a force, and it gives you an equal reaction force. Another example is when you stand on the floor. Gravity pulls you down toward the ground, but the ground pushes back up on you with a normal force. Without that, you'd sink straight through the floor. This law explains everything from how rockets can lift off to why we can walk forward. Action and reaction always work together. Now you've learned the basics of physics. You know what atoms are and how mass and volume are related. You understand how forces affect motion and the difference between mass, weight, and gravity. You've seen how friction can slow things down or help us, and how Newton's 3 laws explain all the motion around us. Everything, from why cars roll to why you stay on Earth, is about physics. Great job, and thanks for watching.